in Chapter 9, we're going to be talking about confidence intervals with means. And typically when we do means, we're going to be looking at t-values. We usually don't know, if we're looking for the population mean, we don't know the population standard deviation. So a lot of times when we're doing these things, we're going to be using a t-distribution versus a normal distribution. Once sample sizes are large enough, typically larger than 30, we can approximate it with the normal distribution, so a normal table. But t-values are more precise of a distribution when we don't know the population standard deviation. So in this, they talk about the t-values in each case, areas under the t-distribution, so very similar to the normal distribution. Except now we have this degrees of freedom term, which is just your sample size minus 1. So degrees of freedom is sample size minus 1. So if it says it has 7 degrees of freedom, that means the sample size was 8. So again, a small sample size. And the area in the right tail is 0.25. Well, we can do this with StatCrunch. We can go look at their tables and try to line things up perfectly. Or we can just go to our t calculator. So my degrees of freedom was 7, and I wanted 0.25 to be in the right tail. So I want the area underneath the curve to be 0.25. So there's 25% in the right tail. So this is my t-value. So this is my critical value, we could call it. So 0.71, how many decimal places they want? 711 would be to 3 decimal places. The right tail is 0.02 with 23 degrees of freedom. We do the exact same way. And we also can do a between with this one. It is symmetric. It just doesn't have the exact same shape as a normal distribution. It's spread a little differently. So that's how you can use the t calculator to help you with these type problems. Very similar to the normal calculator, except this idea of degrees of freedom. Another one to look at is number 5. Number 5, we are being asked what the point estimate is. So just like before with proportions in the previous section, it was p hat plus or minus a margin of error. So now, since we're dealing with mean, it's my x bar plus or minus my margin of error. So it's my sample mean plus or minus my margin of error. And the best point estimate of the population mean is that sample mean, that x bar. So if my lower bound is 17 and my upper bound is 25, so these are the numbers that I got when I did x bar plus e and x bar minus e. So my x bar should be right in the middle of the 17 and 25. So we could just find the average of those two things, and that'll find your point estimate. So 25 plus 17 divided by 2, and we get a good old 21. Now the next thing they're going to be asking is, what is our margin of error? Well, what did I add to 21 to get to 25? 4, and that's also what I subtracted to get 17. But you always could just do your upper bound and subtract your point estimate. So again, we get 4. Another one to look at is number 9. Nine is more of a lengthy process, but it talks about we can assume that it's normally distributed because the sample mean will be approximately, the sample mean will be approximately normal regardless of size sample data. So it doesn't really say anything about it's normally. It says that it's highly skewed right, but since the sample must be large so that the distribution of sample mean will be approximately normal, we're dealing with 1200. So again, much larger than 30, and we can move forward. Oh, so again, it's skewed. We said it was skewed, but it must be large enough. Apologies. So again, it is skewed because it said it was skewed, but if we have a large enough sample size, then we can assume normality. So again, we're looking at some of these criteria. So again, is it 5%, 10%? Is it greater than? Is it less than? So those things that are the criterias. So I'm going to guess one that I know is wrong. So you make sure you find the right answer. Actually, I didn't guess it was wrong. I knew it was wrong. Oh, don't look at that. It was C. And again, that's one of the criteria that your sample has to be less than 5% of the population. I think we discussed that in a different section, just saying that you don't want to pick the same person twice, so that's why you want a sample size less than 5% of your population. And so now we're constructing a confidence interval, and so a 90% confidence interval for the mean. Well, we have this information up here. We know that we had 1,200 people, we had a mean of 0.17 and a standard deviation of 0.06. So let's go to StatCrunch to find that confidence interval. And again, I'm going to go to my, a T statistics. So in the last section we went to proportion statistics. This one will go to T statistics. One sample, and we have a summary where they give us the mean, the standard deviation. So our mean was 0.17, had a standard deviation of 0.06, and I remember the sample size was 1,200. The confidence interval that they're looking for is a 90% confidence interval. So a 90%. And we're going to get that lower limit and upper limit. So if we're going to 3 decimal places, I get 0.167 and 0.173. And then lastly, what does it mean? So we are 90% confident that the true population mean will be in between this 0.167 and 0.173. Again, our sample got us this, so this is a good guess, but we are 90% confident that the true population mean are going to be between these values. And I had one more, number 10, to look at. Number 10 was doing the same thing as far as a confidence interval. So this is our sample size, that's our sample mean, that's our point estimate, and that's the standard deviation. So again, we have everything that we need here to just plug the numbers in and find a lower bound and upper bound. Again, to get there, you go to stat, tstat, one sample with summary. And then we should have all the information that we need right here. Sample mean is 10.4, standard deviation is 16.6, and the sample size is 1012. And we were looking for a 90% again confidence interval. And there's our values. So very easy to compute with StatCrunch.